Okay, the title of the presentation is correct. You're in the right room. The idea was unveiling FastKafka, but in like a couple of slides, everything will be much more clear. So let's start first with our motivation why we developed this library. So we're mainly an AI company, and we were working with our customer to develop a churn prediction model. And that model does what every model does. It predicts. And closer? Okay. Yep. And that model does what every model does. It predicts. And we had to somehow deploy it. So our first idea was to just use Fast API. And it's quite a simple solution. So you init a Fast API object and you decorate your function for predictions with the app.get, and the customer is happy. He can use the REST interface to send the data and get the prediction back. But there was a problem. Our customer uses Kafka internally, so he wanted us to integrate it with Kafka. And we said, before that, the Fast API does all the logic for you. You get the message routing, you get the parsing of the input data, you get the parsing of the output data, and everything is fine and dandy. And he wanted us to integrate it with Kafka. And we said, okay, great, we'll find a library that does something like Fast API. So that initializes a broker, and we just decorate our functions so that it will consume from the input data and publish the predictions on the prediction topic. Surprise, surprise, there was no library that does that, at least not in the API that we wanted to look like. So we got to the drawing board and we described all the things that we needed. So we wanted it to be easy to write some code. We wanted it to be testable. We wanted to have some automatic documentation generation. And we also wanted it to be well maintained. As we didn't find any library that satisfied that, we decided to make our own. So we decided to use Pydantic for parsing the incoming and outgoing data. We use the AI Kafka, an existing Kafka library, as a backend. And we also aligned with the async API to generate the documentation. In the meantime, while we were working on Kafka API, we had a lot of requests from people wanting to use RabbitMQ instead of Kafka. And there was a guy who was working on Propan, who was making an API quite similar to ours, using Pydantic, using AIOPika as a backend, and using async API to generate the documentation. So for the past 2 months, we decided to join our forces and to combine FastKafka and Propan into FastStream to allow people to use AIOPika or Kafka interchangeably through our services. So how is it done? So let's say you want to consume some message from your topic. You can, when you install FastStream, you have a Kafka broker. You initialize it with the address of the Kafka broker. You wrap it in your FastStream application, and then you define your logic of the parsing of the message and your processing logic. And then you just decorate your function with the broker.subscriber, and it handles all the routing. So now your function will subscribe to the input data, and all the messages that are incoming through Kafka will be injected into your on input data function. Yeah. Okay. Oh, yeah. So this is better? Okay. So let's say you want to produce some messages to Kafka. This is quite simple also as consuming. So you create your broker, you wrap it in your FastStream application, and then you decorate your function with the publisher decorator. So this function shown here will subscribe and consume messages from the input data topic. does your processing, and then returns a prediction, which is then published to a prediction topic. And the broker publisher decorator takes the returning value of your function. As a side effect, it pushes it to a Kafka broker. There are other ways to use the publisher. So if you want to like use it once in some other, like you want some CLI that publishes one message, not being reactive to a topic, you can instantiate your broker publisher object. And then when you want to publish something, you just await the publish function of your created publisher. One thing that's like important here is that you can always use your broker as an async context manager, and it will like build up your broker, connect to the Kafka, and when you're done, when you're exiting the context, it will like clean everything up and shut everything down. So in our case, we were working with a JSON format, and one of the first feedbacks we got were from the people that are using Avram. And they wanted to use FastKafka, but with some custom encoding and decoding. And the decoding logic is quite simple to implement. So you have a decoder variable in your subscribers. You define your custom decoder, which accepts a Kafka message. You take the body of the message and do whatever decoding you want, and it will be then injected as input data into your handle function. So in Kafka, the topics are split into partitions so that your consumers can consume the topic in multiple, in parallel. And if you want to be sure that your messages that are interconnected are ending up in the same partition, you have to use keys. And those keys are used to determine on which partition for which topic your message will end up. So it's quite a big feature of Kafka. And in our case, it's as simple as when you're trying to publish something, you just, with your message, define a key, and it will be used internally to determine on which partition your prediction will be published. So let's say next you want to consume multiple messages in batches to like shorten the time of the call to the broker or your parsing of the messages. And that's also quite simple to do. So in your subscriber, you just define the batch equals true, and now your messages will not only be like input data, but they will be parsed into a list of input data messages of the size of the batch that is available on Kafka. And then you can iterate through the messages and handle the messages in batch. The next thing, you want to like publish in batches. This is a feature of Kafka. So when you're publishing, you have to compress the messages and make an API call. So if you want to like have a lower overhead or better compression, you want to publish multiple messages, not just one by one. So to do that, you initialize your publisher with batch equals true. And when you want to use it, you publish multiple messages as a tuple, and it will handle everything for you internally. So the next thing that we had some problems with, so of course our client doesn't want to have Kafka publicly and he wants it secured. So we had to configure our security parameters to connect to the broker correctly. And yeah, this is the signature of AI Kafka producer. AI Kafka producer is used as a backend in FastKafka. So by any means, this is not like a big criticism we are sending on the shoulders of giants, but it's quite an ununderstandable thing to go through. And after like just deriving only the security parameters, you can see there are quite a few of them that you don't need, and in the documentation there are quite a few that aren't explained. So in our case, we wanted to use SASL with Scrum SHA-256 to authorize to Kafka. And to do it in Neo Kafka producer, you have to like define that you're encrypting with SSL using SASL. you have to define the SASL mechanism, and the one trick thing that took us 2 days to figure out, the SASL plain password and the SASL plain username, which is documented as being used only in the plain type, is used also in Scrum. So it took us quite a few of tries to like figure out what to inject where to have it working. In the FastKafka case and also FastStream case, this is quite, in my opinion, more simple. So you import your security object. In your case, if you want to use SASL Scrum 256, you import it, you pass the SSL context to it, and then you define your username and password. And when you initialize your Kafka broker, you pass the security object to it, and like everything is fine and dandy, and it works. If for any case you want to use plain text, you just need to, in this case, it's quite simple. You just need to change the security object and everything else will be figured out for you. So the next part was how to do the testing. So we got some feedback on our first case. We did some context managers that connected your broker to a real Kafka broker, which is not ideal because you don't want to always lose time on your test to connect and disconnect and wait for messages. You just want to like directly test if your broker is like sending and receiving. So in our case, you have a test Kafka broker context manager in which you pass a broker and it will patch the consumers, the subscribers and producers of your broker to connect in memory, not connect to the real broker. So in this case, we will subscribe also to a prediction topic so that we can check if there are any produced messages. And then we will send test data to the broker and check if the broker has consumed test messages and check if a broker has produced a prediction. Hopefully it will. If for any case you want to test with a real broker, so you have your service, you really don't want to deploy it, but you want to be completely sure that it will connect and work with a real Kafka broker, it's simple as this. So in your context manager, you define with real, it will start up your broker, connect it to the real one, and then all the underlying like lines for testing, publishing and asserting that it was called is quite the same as using an in-memory broker. So this was all like part of Kafka, but what if you want to use a Rabbit broker? So our first example was using a Kafka broker. You have a publisher, you publish to a prediction topic, you're encoding, you're subscribing and everything. So to use a Rabbit broker, you just do this. So you have a Rabbit broker object, which knows how to connect to a RabbitMQ. You just change it from Kafka to Rabbit, and there are some like configurations that are different in Kafka and broker, but that's like the advanced part. In like 80% of the cases, if you just want to consume and produce something, you're done. So you've probably noticed that you have to wrap your broker into a FastStream object. So why is this important? So to use our documentation generation and to use the lifespan hooks. So if you want to do something before you connect to the broker, after when you're cleaning up, you have to wrap it in a FastStream. It has lifespan hooks and it takes care of serving and the documentation generation for you. So how to serve the app? FastStream comes with a CLI. So when you're done with developing your application, you just pass, you call the FastStream run, and you just pass your Python module, the application, or the application py file, which has a app symbol defined, which is a type of FastStream, and it will like take care of everything for you. So it will run your application and it will take care of the cleanup when you shut it down. What's great about this? So if you want to do the parallelization, if you want to spin up multiple consumers and your applications, you just define the number of workers and it will be done in different processes and it will process messages in parallel. What about the documentation? So you have the CLI to generate the documentation. So the generate part will take your application, parse it, and create a JSON structure that can be uploaded to async API site, and then you'll get pretty nice documentation of your application. Or if you don't want to upload it and you want to just serve it, you can use the serve part. And the documentation looks like this. So you have your subscribers documented. It's reading from input data. In our case, it's a fairly common machine learning problem, the iris setosa dataset. So it's consuming the parts of iris flowers, and it's publishing to a predictions topic, and it's publishing a string of predicted species of the incoming flower. And yeah, also you have to have your connections documented. So the service you want to connect, in this case, this is localhost, the type is Kafka, and you have some like security protocols and what port and whatnot. What's planned in the future? So one of the things in Kafka is that when you, by default, when you consume a message, is consumed. So you cannot like restart that process. And we we want to enable that you don't commit that you have consumed the message immediately, but only after you've processed it. So you'll have a message.acknowledge, and when you're sure that you're like done with the processing of the message, you can acknowledge it, and like everything is saved to Kafka. And also you want to have possibly multiple brokers. So let's say you want to copy or consume from remote the flowers, and you want to publish the predictions onto your local broker. So you can define two brokers. One connects to the remote, one connects to your local host. And then you decorate your function with the subscribers and publisher, and it will consume from remote and publish to a local Kafka broker. In some case, if you want to like consume from Rabbit and produce to Kafka, you can do just that. So it's quite a neat thing if you want to like connect to different kinds of brokers, if for any case you want to do that. And like some tips and tricks that we've learned while working on these projects. So FastKafka was initially done, we come from like an AI background. So we love to do our work inside of Jupyter notebooks. So all of the source code was done and tested in Jupyter notebooks. And it was really nice for us, but we got very little collaboration from other people. And mainly the objection was, I don't know how to work with IPy and BIF files. And in the Propan case, they got quite a lot more collaboration, and it was because the Py files and the Python structure is much more familiar with the Python users, so they would be much more happy to like dig into that code. Also, if you want people to work on your documentation, we initially worked with Docusaurus, so it takes your MD files and publishes it as a site, but the structure of those documentation is quite more complex than mkdocs, and you get barely nothing better than just using the mkdocs, and the Python community is much more familiar with using mkdocs, so stick with the basics. Also, why we published this library is because we wanted the world to see that we did something good, and we wanted people to use it and to shorten their time of development. But also, like we wanted to, while the people are using it, they will test it in ways that we haven't figured out. So it's very beneficial for us to get the feedback of the things that need to be included to make it better. Also, you've certainly heard of test-driven development. So write tests and you implement your application to pass those tests. In our case, we've copied a lot of like the structure from the Fast API, and they have like a beautiful thing that all the code that is in the documentation is being cited from the tested code. So all the code that you can see, you can copy paste, and it's guaranteed that it will work because it's tested. And also, when you're like first writing the docs, you will fish out many of the API difficult things, and in the end, when you're like done with the docs and go to the implementation, the API will be much more prettier than if you just start implementing. Also, FastStream has been released today. And if we didn't have this conference, I believe that we would release it like 2 months later. But because we had a concrete deadline, and it's like an open source, so nobody's pushing us, we really had to dig in and spend the past month and a half to like rewrite everything and make everything ready and make everything tested for the people to use it. Yeah, and also don't be afraid to rewrite it if you're wiser. So we had a huge FastKafka code base, and then we decided, okay, now we know better, we'll do it better. And from my side, I wasn't really happy at the first like idea of it, because we were like really working hard on it. But a lot of good ideas came from it, and we wouldn't be able to like write it inside of FastKafka. But here, where we had a like clean slate, it was much more easier to like do the redesign. And yeah, also don't release on Friday or Monday. We're breaking this today, but it's not really like if you release on Friday, you'll have a shitty weekend. It's really, from our case, we are like star goblins. So we really like to see some stars on the GitHub. And if you release on Friday, everybody's tired, everybody's going home, nobody's going to see that you have released something. And if you release it on Monday, like everybody's starting to work and nobody has the time to like check out new libraries. So when we were releasing on Friday or Monday, we had like a little response. But when we started releasing on Tuesday for us, it was like much more feedback from the people than like on those 2 like bad days. And yeah, what's the point? We want you to like at least open an issue, try it out, start it, go to the GitHub, check it out. It's been released today. It's in like it's been like in beta, but on Monday we plan to like polish all the docs, and release it completely. So yeah, check it out. And also, we have our Discord channel. It's called FastKafka because it's like legacy. But yeah, go there, say hi, ask us anything, how to use it. We'll be happy to answer to you. Thank you.